Hey, what's up, guys? Cheng here again. And so this time, let's take a look at LeetCode problem number 435, non-overlapping intervals. Pretty classic intervals problem. So you're given like a collection of intervals. Find the minimum number of intervals you need to remove to make the rest of the intervals non-overlapping. Okay. So, this problem can be converted to like what? To the most to be what's the maximum number of intervals we can put, right? We can put into the range of into this like a timeline that none none of there's no overlapping, right? So it's equivalent to find the minimum number of that. Okay. So then the problem is becoming the converts to we want to like accommodate as many as non-overlapping intervals as possible. Okay, so how are we gonna do it? So I mean, whenever you guys see an intervals problem, mm, the first things come to your mind is you have to either sort by the start date or the end date. And in this case, we should sort by the end date. So why is that? This is also like a greedy idea here because if we sort by the end date, it means that every time we're only we're only trying to add like the interval that ends the earliest. So if every time we always pick the intervals that ends earliest, it means that we have more time or we have more chances that we can accommodate more intervals after the current end time, right? I mean, if we sort by the start time, then we won't, right? Since we're finding the maximum intervals we want to fit. For example, if we have a 1 and 10 here, okay? It starts at time 1 and ends at 10. And we have some others, 2, 3, 3, 4, and 5, 6, okay? If we sort by the start date, not the end date, and then we will pick the 110 first. But if we pick the 110, then it means that anything that before 10 cannot be fit, cannot be accommodated in this case. So we have to wait until the 10 is finished. That's against our assumptions, our like our purpose here. So the correct way of sorting these intervals for this problem so that we can have the most intervals scheduled is sort by the end date. Mm, yeah. And and every time when you guys see a minimum, there are like a bunch of other ways you can possibly use when you see a minimum question. Another one is the a DP, right? So for DPs, you can also calculate the minimum value. I think for this problem, we'll be also using like a DP in a way. Basically, every time when we have like a valid interval, so we're gonna use we're gonna store the current ending date, right? So that's kind of like a DP concept here. So one is DP, the other one is the BFS search, right? So for BFS search, it's always to find the minimum path, right? The minimum path or the minimum like days to whatever to do something, right? But in this case, there's no graph or tree-like structures, okay? So the BFS is not a valid approach here. And there's also a binary search, okay? So the binary search can also be used to find the minimum value for something. But for binary search, we have to mm, we need to have a range, right? We need to have a range and assorted numbers in that range. So that's, I mean, but in this problem, even though we're sorting it, but we're not looking for like a specific like values in the range here, right? We're trying to see how many values we can put into the range. Yeah, and there's no target. With the binary search, usually we're gonna have like another like a number another target, like target numbers here. Something like uh let's say if we want to fit in the like case intervals, something like that, right? We need a target so that we can do the binary search. But here we don't have a target, that's why we cannot use binary search either. So then it just leaves us the like a greedy algorithms here, right? So for greedy, we can also use to find the minimum or maximum, but in this case, it's minimum. That's why we decide to use the greedy uh, algorithms to solve this problem. Okay. Mm. Basically, for the greedy problem, like I said, we always pick the earliest, the smallest ending time possible, so that we basically we're saving. Basically, we're leaving more times for the remaining like intervals. That's the greedy idea here. Mm. Okay, so with that being said, let's try to code this problem up here. So like I said, we need to sort it, right? So to sort it, we sort it by the ending time. So we need to have like a lambda key here, okay? Lambda and x dot x1. That's how we do a sort by the end time. Then I'm gonna have like the answer equals to 0, right? And then like I said, since we're going to need a like to previous ending time so that we can use, right? Because every time when we have like a valid like valid intervals, I'm going to update this pre-ending pre-end variables so that the next one can use this one to use his start time to compare with the previous ending time. If there's no intervals, then it's a valid one. Otherwise, it's not. Okay. But since it says the numbers is integers, so I mean there could be negative numbers in this case. At least there's some negative numbers in the test cases, so that to start this previously ending, we cannot use 0. Okay, we have to use the smallest number possible. So after that, all it's left is just loop through the intervals here. We're gonna have start and end in intervals. Okay. And every time when we have a new interval, so we simply do a check. If the s is smaller than the previous ending, right? If that's the case, then we know, okay, we cannot accommodate these intervals. So we have to skip that. And then we'll basically add our answer by 1. Else what? Else we simply update the ending with the current end. In the end, we return the answer. Okay. Mm, yeah, I think that's pretty much it is. Let's try to run it. So, it's test case passed, submit. Yeah, it works. So, I mean, a pretty classic intervals problem, but in this case, I mean, we have to sort by the ending time. So, and then here we're using like a DP idea here, since we are like saving the previously result, right? So the DP is like this, right? So I mean, we use the previous result to calculate the current one. And but since the why we can only care why we only care about the previous one, not the previous two ones or the previous three intervals. It's because we're sorting the intervals have already been sorted by the end date. by the end time, right? And so that this pre-ending is always increasing. Mm, so I mean, if this current as is smaller than the previously ending, we know, okay, so it must have already overlap with at least one intervals. For example, let's say if we have 1, 2, right, and then the next one is 3 and 4, okay, and then like 5 and 6, okay, and then we have like another one. It's like, let's say the 2 and 8, right? So this is the as and end. The previous ending is 6, right? The previously ending. And we see, okay, so the 2 is smaller than 6. And then we know at least this one will be overlapping with this previous one. It could also be overlapping with this 3 and 4, but we don't care, right? All we care is that because the ending will always be bigger, right? So because as if it's overlapping with this one, that's fine. We don't need to know if it's overlapping with this one or not, right? As long as there's some overlapping, we know we cannot use this one. That's all we need, so that we don't have to loop through everything from the previously added intervals because the ending time they're all sorted, right? So all we need to care is we just need to know the previously ending time, which is the biggest one uh, so far, right? Okay, cool. I think that's it for this problem. I mean, okay, those space complexity. I mean, so the time complexity to sort it, I think it's gonna be a O of n log n, right? To sort it, and here it's like O of n, right? So that's so it's for total, it's still O of n log n, and the space is O1. We're not using any of the we're not using any of the extra space here. Just one variable here. Yeah, cool. I think that's it for this problem. Yeah, I think one takeaway from this is always when you have like intervals problem, always sort either by start time or by the end time. So for this one, it's by end time since we need to fit in the most the most intervals, right? Mm. Cool. I think that's it for this problem. Thank you so much for watching the videos, guys, and stay tuned. See you guys soon. Bye bye.